Hello, Math 8 scholars. It's Mrs. Carbajal here. Today, I wanted to talk to you guys about translations, and then later on, it will be reflections. But for today's video, you should have your translations foldable in front of you. My marker just burst on me right now, so I'm going to be rocking this marker stain, so just bear with me here. So I have been uploading some material on translations, and I hope that by now that you know that a transformation is a type of, translation is a type of transformation, meaning to transform, to change. It's the same as an object sliding or shifting around. Okay, so I just grabbed the nearest item I have, and it happens to be this Lego minifig. So if I have this Lego minifig here, notice how he is just kind of staring up at the camera, and then I can translate him. I can slide him around in front of me. Notice how I'm not turning him or twisting him in any way. I'm not flipping him around. So this is called orientation. The way that he's facing is going to be the same. He's just kind of sliding around. So this is a translation, like a slide. Okay, so by now that we should know that translations, they look exactly the same after we move them. They're just in a different place. Okay, and you're gonna start seeing a lot of algebraic representations of translations today. Don't get scared, it's gonna be fine. So let's say we had a translation and we moved it 2 units to the right and 1 unit down. Think of a number line. If I moved on my number line 2 units to the right, I'm moving in a positive direction. So notice here, when they moved 2 units to the right, they added 2 to the original coordinate. 1 unit down, again, if I'm going downwards, I'm removing 1. Notice how they took that y coordinate, for example, and they removed 1. So that's what we're going to be working towards today, is eventually, maybe we don't even have to do the translation and we're able to tell the new coordinate just based on the description. Okay, a couple things if you haven't figured this out yet. The before image, the thing that we start with first, is called the pre-image. So if you look at these examples, they're just like A, B, C. I think I have an A right here. I try to model that for you in blue if it's showing up on the camera. And then the after I slid it, after I rotated it, after I reflected it, that's called the image. Okay, so this is the after image. Okay, notice how I'm trying to highlight those in red for you. Okay, let's go ahead and move on. In this example, you see here that they moved this triangle ABC 6 units to the right, and then it also was shifted 4 units down. So we're going to be practicing some of that right now. Okay, so as you open up your foldable, the first question is asking which of these is, which of the following is a translation. So I actually have a rough time with this unit because it's very visual, and sometimes my brain does not compute. So when I return next week, I'll be giving you guys these little plastic pieces for you to use and to write on. So I already went ahead and did that, and I traced over this triangle ABC. Now I know that a translation is just a slide. So I should be able to just slide this triangle around, not turn it, not twist it, and I should match it from its pre-image to its image. So here's its pre-image, here's the image. That doesn't look right. Here's my pre-image, here's my image. Ooh, option C does not look right. Here is my pre-image, here is my image. Ooh, not quite, they look flipped around. Here is my pre-image, and here is my image. Winner, winner, chicken dinner. So option B is a translation, because notice how the orientation has not changed. It hasn't turned, it hasn't twisted, it just slid over to the right. So option B here. Again, I have my little sentence starter. Feel free to pause the video if you want to catch up at any time, but we know that letter B represents a translation because it represents a slide or a shift. And the orientation has not changed. Okay, I did not turn in any way. Okay, so that's just basically what a translation is. Okay, now let's actually do a translation. So what we're going to go ahead and do is figure out what happened here. And I know this isn't marked on your paper, so please go ahead and interact with your notes. Half the battle is just knowing which one is the pre-image and which one is the image. So in this second example, we have this, they don't really label it here, but NHOT. This is a parallelogram. Notice how there's just the letters, whereas this one over here has these little tick marks on them. In geometry, those are called prime notations. And so this indicates to us that this was the before, this was the pre-image, and this is the after. This is called the image. So sometimes it's good to just note that. So we're going to go ahead and describe it. So if I take any point I feel like maybe I want to focus on just n to n prime, I can count. It clearly has moved to the right. Let's see how many units it has moved to the right. 1, 2, 3, 4, 5, 6, 7 units to the right. So I can see that's moved 7 units to the right. Okay, now it's obviously gone downwards. Let's see how many units it's gone downwards. 1, 2, 3, 4, 5. 5 units down. That's it. So we're just describing the translation that we're seeing. And this should be true for all of these vertices, all of these points. So H should also be 7 units to the right and 5 units down. Same with O and same with T. Okay, so now that we've described, let's move on to actually doing the translation. So we have this triangle SUN. Notice how there's no prime marks on it. So this means that this is our pre-image. I'll go ahead and label that pre-image. Okay, again, this is the before. They went ahead and labeled our coordinates for us, which was nice. Now our job is to figure out what the new coordinates are as a result of it moving 5 units to the right and 3 units down. Eventually, what we want to do is be able to just state the coordinates without actually having to physically move it. We'll get there. So I'm going to go ahead and just take each of these vertices and move it 5 units to the right. 1, 2, 3, 4, 5. 3 units down. 1, 2, 3. So this is my new S, and we call that S prime. Okay, I'm going to do that with each vertices. So here's U, 5 to the right. 1, 2, 3, 4, 5. 3 units down. 1, 2, 3. U prime. 1, 2, 3, 4, 5. Down 3. 1, 2, 3. So the one good thing about this unit is you'll know if you're right. Okay, because what we know about translations is they are congruent, meaning the same size, same shape, same angle, it just moved. So if your answer does not look the same, then it's an indication that something is wrong. Okay, so then all I have to do now is name my coordinates. Now, eventually what we want to do, we want to get to a place where eventually we don't actually need to do this. And we could just look at the pre-image and state the answer. And this is how we would eventually do that. 5 units to the right on the number line means we're going in the positive direction. This means I'm going to add 5 to my x coordinate. 3 units down, well, down just kind of sounds negative. So this is going to be subtract 3 from my y coordinate. So if I didn't feel like actually translating, I could just take the x coordinate and add 5. So -6 plus 5 is -1. If I wanted to take the y coordinate and just subtract the 3 from it, I would get 6 minus 3, which is 3. Okay, let's see if I was correct. Is the S at -1, +3? It is. Okay, so these are two different ways. Again, if you want to just do the algebraic representation, you can do that. If not, you can translate and just state the answer. Again, add 5, subtract 3, so that's a -1. What I've done here is I've added 5, so that is a +3. Subtract 3, -1. Again, I just use algebraic representation. If not, I could just state the answers I'm seeing in the coordinates. Okay, all right, and let's see if we can do one last one. Example 4. Okay, it's telling us to take this pre-image and to go ahead and translate it 2 units to the left. So I'm going to take each of one of those vertices, 2 to the left and 6 up. 1, 2, 1, 2, 3, 4, 5, 6. That would be I prime. Okay, I'm going to go 2 units to the left. 1, 2, 3, 4, 5, 6. R prime. 1, 2, 1, 2, 3, 4, 5, 6. Again, I know I have this correct. If when I'm done, this looks like a trapezoid, same size, same shape, same orientation. It's just moved over 2 units to the left and 6 up. 1, 2, 1, 2, 3, 4, 5, 6. That would be B prime. I'll go ahead and connect those vertices. And to me, visually, that looks like it's the same trapezoid, same size, same shape. Nothing has been turned or twisted. It's just slid over. Okay, and I'll let you guys have a moment to go ahead and fill in those new coordinates, whether you want to do the math on it or whether you just want to look at the answers and state them on that. All right, stay tuned for video number 2.